So when it comes to off-the-shelf lighting kits for V2 EMO, there's really only one option, and it's the lighting kits available through printed-droid.com. So I thought I would take a closer look at what comes in the set, what options you have available to you, and what modifications to some of the parts you're going to need in order to incorporate these lights. So let's take a closer look. All right, so what you see here is everything that you get with a complete set of the version 2 V2 EMO lights from printed-droid.com. Printed-Droid is based out of Germany. Their prices are in euros. The full set with everything you see here was 89 euros. This control board, you can choose to not include it and reduce the price by 20 euros. So it'd be 69 euros just for the LED boards. There's a version 1 and there's a version 2, and if you're not familiar with the difference, the version 1 B2 was a very early sort of proof of concept build, and the size and scale ended up being a little bit smaller than the actual B2. In fact, the version 2 was scaled up by about 7.5% or so. So the version 1 logics will not fit in a version 2 build. There are a few other changes that they made in addition to scaling them up. These body lights, the large neopixels that you see here, were replaced with these much smaller RGBW, I think, neopixels. So they did that on all three of the body lights, as well as the little triangular light that is up next to the eye. So those are different from the earlier version. And yeah, basically this is all that you get. The header pins need to be soldered on. I haven't done so on this one. I'm not sure yet if I'm going to use this one, and if so, how I'm going to use it. But that's basically all that you get here. So when it comes to print files, Printed-Droid does include a link to download some STL files that are modified to support the riser lights as well as the eye lights. Those files, however, are based off of the version 1B files. They're really not going to work well for a version 2. There are alternatives, though. When it comes to the risers, another builder created some modified risers, and these are available in the mods folder in the B2 version 2 print files. They have a cutout for the little LED panel. There are some holes there for some heat set inserts, and then there's a little ladder piece that goes in there as well. Additionally, I got some polycarbonate. It's just some smoked gray polycarbonate. I scuffed up the back side of that, cut that to fit. So that goes right in there, gives you a nice diffuse effect. And then you can just pop this in there. And then you've got your, I think it's M2 or M2.5 size hardware. And there we go. And so these are basically the modified risers, and these will fit just fine into the existing version 2 build. Likewise, for the larger one, it's basically the same concept. When it comes to the eye, however, that's a little bit different. So when the main eye lights were developed, the idea was that you would have the outer ring, and then you would have this cool inner ring. And these are actually the version, or the Printed-Droid files that have been scaled up to match the size of the version 2 eye. The idea being that you would have these three parts in solid or opaque filament, and then you would fill the gaps with either a translucent or a white filament, and then those would line up with the rings and illuminate the whole 2-ring concept. However, with the advent of the V2 files, there have been a lot of updates with additional details on the eye that are not reflected in the files from Printed-Droid. So you really kind of have an option. You could use the scaled up Printed-Droid files, which will give you the nice dual ring effect, but at the expense of losing some of the additional details. Or what I decided to do was I experimented with modifying this version 2i and doing a 2-color print, I didn't have any transparent filament, but I found that printing the lower levels with white and it would line up nicely with the lights behind it, and even with these really cool details here, it actually produces a really pretty cool effect. In order to get the panels to sit flush on the back, I modified this with a handful of cutouts for the header pins and so forth, and then those will fit on there really nice. Now you'll notice though that unfortunately the inner ring of NeoPixels does not line up with that. Now if I had a dual color printer or wanted to do something really cool, maybe I could print this outer layer here also in white, but for now I've decided to just stick with getting the outer ring lit and go with that. Similarly for the small eye, again, just doing a simple color change right before these cross details are done gives a really pretty cool effect. Again, with trying to get the panels to sit flush, I did create a little bracket. I'll make these available over on Printables that allows you then to hold that securely in place. So with the print files worked out, the next question becomes, how do you hook all this stuff up? All right, so before we get into the details of hooking everything up and connecting everything, now's the time to talk about this control board. Printed-Droid is a little bit light on documentation. The idea behind this board is that it uses an ESP32 as its main brain, which provides a lot of cool functionality like wireless communication and so forth. There's also slots over here for a DF Mini player for audio, if that's something that you need. Now, there's no documentation about which ESP32 it takes, and it took me a while to figure out that it's a D1 Mini. I was able to pick this up, and then this slots right into everything here. Let me make sure that that's in there correctly. And then you'll see that there are a bunch of connections along the outer edges here, both DuPont style connectors as well as screw type connectors. One of the nice things this board provides is power distribution. It requires a steady 5 volts input here to power the ESP32, and then that 5 volts is relayed to all of these outputs. However, one of the other big problems that I found with this particular board is there was no documentation as to what outputs from the ESP32 mapped to the pins here. You'll see on the sides that they have they're labeled D1, D2, D3, and I think B1, B2, B3. And all the documentation I saw for the ESP32, there was nothing that said what D1 is or B1 is. I basically had to take out my multimeter and do a continuity check between each of these signal pins and the pins along here. And what I found was kind of surprising. For instance, D1 actually maps to a non-digital output pin. It's actually the TCK pin on the ESP32, so I don't think you can even use D1. You know, the others do map to I/O pins. You know, it took a while for me to figure that out, and I kind of wish that they had that sort of documentation. The other important thing to keep in mind when you're wiring these is if we look at the pin orientation, you'll notice that positive voltage is on one side, ground is on the other, and the signal is in the middle. This is different from your typical servo connection where the positive voltage is in the middle. That's actually kind of a nice safety feature. If you put the plug in backwards, you're not going to fry the component. So you have to be extremely mindful of your polarity when you create your wires and when you connect everything. Likewise, the pins here follow that same pattern. So as long as you're connecting from like to like, you're going to be fine. However, there are some additional pins down here, and the 27, 32, and 33, these all map to other assignable output pins, so you could also connect something there. These follow the servo convention. You'll notice that positive voltage is in the middle, signal is on the top and ground is on the bottom. So if you are going to connect any of your lights to these outputs, make sure that you swap the wires along the run correctly, and then make sure that you put the correct pin or the connect end onto each board. So with all those things figured out, I went ahead and tried to connect everything and use it. And in the end, the other thing that kind of annoyed me was I generally use DuPont connectors because I'm pretty capable of making the connectors, and I've got lots of those around. With the board oriented this way and with the USB connected here, you can't use the DuPont connectors and program it at the same time, which makes troubleshooting and coding it a little bit of a challenge. And especially when you factor in the fact that you can't really use this pin, that leaves you only 5 assignable outputs there. And well, that's the 5 lights with the 3 risers and the 2 eyes. That's without using the little triangular light. I could use one of these pins for that, but already I'm kind of limited. So with all those considerations in place, I've decided not to use this. I'm really not going to be using a DF mini player on this. The wireless communication might be kind of nice, but in the end, I'm still going to have to power anything anyway. So, there's not much of a benefit to having the wireless communication. So instead, I've decided to go with a pair of Arduino Nanos. So one of the reasons I think it also makes sense to use Nanos instead of the single control board is based on the positioning and the placement of B's lights. You basically have 2 different systems. You've got the riser lights, which are at the mid-level, and then you've got everything else that's up in the head. And having a single control board means that you have to run those longer connections from either the body up into the head or from the head down into the body. By using 2 nanos, I can basically split that out and just have 1 nano in the body and 1 nano in the head and just pass power into each one. But I did mention before about one of the nice benefits of this control board was having all the power distribution taken care of for you, which you don't really necessarily have with the Arduino. So we have this nano here. This is the 5 volts in that powers the Arduino. And then here we've got a ground and we have 4 signal wires, even though we're only using 3. And the reason for that is I did find these handy little servo distribution breakout boards. And these are perfect for this sort of application. What this does is it takes a power voltage in this case it could be 5 volts, but if we were powering something maybe like servos that required higher voltage, you could pass whatever voltage in that you want. And then you have these 4 unique signal wires that each feed one of these servo connectors. Now remember I mentioned before though about being careful that on the servo connection side you've got plus 5 volts in the middle and signal on one end. On our lights we have to make sure that we swap those wires and make sure that the 5 volts goes to one end and the signal wire goes to the middle, at least on the light end. So this in conjunction with the Arduino makes the hookup actually quite straightforward. So we have our signal wires plus a ground to connect to this. This also gets its voltage, it's 5 volts from the power supply. And then I simply have, these are my 3 connections that go to the riser lights. You'll notice that voltage is in the middle at this end. And if we go to one of the connectors, the voltage is now on the outside with signal wire in the middle. So with this, now I can connect these 3 to this breakout board and its own Arduino Nano, and then for the eyes I'll do something similar in the head. So now that we've got everything hooked back up, you can kind of see how everything comes together. It is worth noting on the head light boards, it actually allows you to daisy chain these if you'd like. There's an input as well as an output. I won't get too detailed into the programming for the NeoPixels, but if you daisy chain them, then you can use a single data line, and the indexes of the neopixels will just continue to grow. So, you know, you've got a certain number for the outer ring, certain number for the inner ring, and then you would have these that would be appended to that, and then you could potentially have the little triangular light as well. You don't have to do that. You can also just have each one have its own separate signal wire. It really kind of depends on how you want these to work. Right now I've just got some basic sketches in here that all three of these are basically changing color at the same time. I don't even have like a little blink or sparkle effect. I might do that. Just kind of depends on how you want it to work, but overall the performance of these is great. I've got the overhead lights on, so they're a little bit washed out. I will be experimenting with at least putting a little bit of dusting of paint over this to try and even that out and make it a little more metallic looking. But yeah, I think once you look at it from an angle, and once there's a little bit of shadow from B's hat, I think the effect will be pretty effective. So I would like to be able to find a way to leverage more of that central ring of lights. But for now, I think this is gonna do something that I can always revisit later on. After all, droid builds are never fully complete. So I think that about covers it for this. I've been meaning to do this for a while. I've had this stuff sitting on my workbench for quite some time. And I hope this helps maybe clarify some of the differences between the V1 lights and the V2 lights that are available on printed-droid. But I do think that B will definitely benefit from having a little bit of lighting, a little more dynamic. So anyway, thanks all for watching, and I'll talk to you next time.